We are going ahead with our knowledge sessions on one Marina. And for this, I request Architect Reza Kabul, Mr. Manmohan Maniyar of MAHIMTURA Consultants, and Mr. Pragnesh Patel of PANKAJ DHARKAR Associates to please come on stage for the same.
Good evening. It's great to be back in Nashik. It's like home to me, and I've been partly my schooling I've done in Nashik, in Devlali. So it's home to me, and I enjoy coming back. And it's a great honor. Thank you, iDAC. So let me first just this thing. The topic was vertical cities. Vertical cities means to me is that you take a city and you do it vertically. So in that context, if you look at it, you have everything that is there in a city in a tower. So we should look at it that way and not look at it as an isolated tower. If you look at it as an isolated tower, it is a problem. So I'm just wanting to correct, it's not a vertical city that Nashik is going vertical, but vertical city means that a city going vertical. So it's a vertical city. So today, I'm going to be presenting one of my towers that is under construction in Mumbai, and we call it the One Marina. So this tower is, I have my support with my structural team from MAHIMTURA consultant Manmohan and Pragnesh from PDA architects, PDA consultants. So, okay, so that's One Marina, and it's on a very prime location, and we call it the Queen's Necklace. The Mumbai, of course, the Queen is no more, but we still have the necklace. And we are doing the jewel in the necklace of the Queen. So it's on a very prime location in on the Marine Drive, the Queen's Necklace. It's just off the sea coast. This tower would not have been possible if there was no CRZ lifting. So this is a byproduct of the CRZ relaxation. That's Mumbai, and that's where our tower is. It's in the bay. So this is how the site is today. It was today, of course, it's changed quite a bit. We have the site which is just off the coast, and we have nothing which is obstructing the views. So this is almost 2.2 kilometers from the site. You're on the left-hand side, and the right-hand side as well. You've got 2 kilometers, which has got unobstructed view. And the biggest challenge, the client wanted is, he said when we started the project, he said, I want all my flats to face the sea. So all the flats should have a view. And it was a big challenge because the plot is not very wide. It's a lakh square feet, and it's 350 meters away from the main sea. And as you see out here, we've got these are all the gymkhanas that we have, the police gymkhana, the Hindu gymkhana, the Islam gymkhana, and nothing is going to come up in front. So it stands at 250 meters tall. We've got nothing in the front. That's the Arabian Sea. Only thing that's coming out there is your coastal road, and the coastal road is landing over there. So it's very strategically located. So as I said, that's the layout of the plan, the tower. That's the plot, and we've got, that's my main access to the site. And we have one access from there as well as a very narrow access. We have, actually this is a building which is existing, and we are doing a redevelopment. So this is the sale component, and then behind this we've got another tower which is your rehab component. So the other thing why we wanted to, firstly we wanted the views from the main, this thing, we've got the sea in the front. And so we wanted the views in the front, and the backside we have the tower, which is a 100-meter tower again for the rehab. So we didn't want any of the apartments facing the rehab component, and we wanted to get the best of views. So that's my ground floor where you have the entrance lobby. You come in, and it's a 7.2-meter entrance lobby. And so once you get into the entrance lobby, that's how the look and feel of the entrance lobby is. That's the waiting area. It's a very high-end residential building. That's the lift lobby areas. And where you have the drop-off, we've got a very nice water feature, a musical water fountain, and the lobby. That's the drop-off area again. And then we have got 2 parking levels. Here, the major challenge that we had was the soil condition. I think the structural team would be telling you a bit more about that. So we had total sandy soil over there. And once we went deeper, so we had to go in, of course, we had to fit in the parking. So we went in for 2 basements and 8 levels of podium parking. That's, again, a detail of the lobby. So we have 8 elevators, all from 5 meters to 6 meters a second. We did a traffic analysis looking at the number of apartments that we have. That's our podium parking and the iDAC. So once you come on the iDAC, you have total unobstructed view from here. You can get the sea view, and we have the pool. We have got double level clubhouse, which is there. It's a very elaborate and a very extensive clubhouse that we are having, and a major pool area. That's some of the views of the iDAC and that's again a closer look at the iDAC. We have the gym out there. So we have the gym looking at the pool and overlooking the sea. So it's a very challenging design because we have, all the apartments facing the sea. And so we've got, because of the, you saw the views that were there, from this side as well as from this side. So we took all the apartments facing the sea, and we got a back which is totally dead. Now, he would explain more, because we had certain issues, because when you do a tower like this, and a high-rise tower especially, with the core which is getting detached from the main core, the core getting detached from the tower, it's a little challenge, but my structural team overcame it after we did the wind tunnel testing and everything. So we've got several, options for the apartments. So we've got 2s, 3s, 4s, 5s, and as we go higher, there's a high-rise part which comes in. Now, here looking at the facade, we haven't gone in for a total glazed facade. It's every level has it, individual facade. So we've broken it up so that, the cost is controlled. And you guys can tell me more about it. But we did a lot of this thing. And then, we have 2 levels of amenities. One is on the 8th floor, and one is on the 69th floor, right? So we have 68th floor. So that's again another amenity level. And then you have the sky villas. There are about 4 sky villas. Each are going to be used by the developers themselves. So this is a 250 meters. We've got 30 meters of podium, the iDAC. 106 meters are smaller apartments. Then we project out, we go to 106. And the entire thing is 250 meters. So then we started work, and Of course, we did a raft foundation, and so that's the work progress. Now we are up almost to the ground floor. We had 2 basements. We had a raft of about 2 meter plus because of the upliftment being close to the sea. I'll ask Manmohan to carry on, please.
So any such high-rise is a very challenge to bring it in the reality, because basically 2 things we want, strength and stiffness. So, and all that strength and stiffness, we have to get it satisfying all other requirements. So you can see this is the structural plan at raft foundation level. This is the raft foundation. A complete raft is given here for tower area, and separate isolated footings are given for non-tower area. The depth of the raft is 2.8 meters. And upper strata was totally sandy soil. It was just flowable soil. So decision of basements was taken, and luckily at 8-meter level there was a very nice strata which assured it was giving us 200 tons per square meter of bearing capacity. So these are the basic layouts. Now this tower is a 250-meter high tower. 250-meter high tower has its number of demands, and we have to get certain strong core. So that is there. Then all these lifts and all that are we utilize for our strength and stiffness demand. But out of the challenge of this shape, the structure's dynamic behavior was not as desired. It was a big challenge for us. The structure first mode was going in torsion, which is undesirable, which is not a good thing, not acceptable. So of course we have done a lot of permutation, combination in number of, and we utilize all these perimeter walls. And the architectural intent was also like that, to hide this side, and we utilize all this. We utilize all these sides, and a strong core is established, and the modes are then properly set.
So we had a lot of constraints, like we had back and forth with the structural team, because we wanted, we didn't want certain columns, we wanted to, join certain apartments, and as always there are in all the projects. So we had those challenges, but we overcame that.
Same way, high-rises are going, and very importantly in this, after doing all these whatever permutation combinations, then also we were deficient of the total permissible deformation. The structure's deformation under wind load was not under control, and then we utilize a structural system that is called as outrigger. So there are 1, 2, and 3 outriggers are provided at these 3 levels, and because of this, I will explain how we reduce the deflection. So in the next slide, I will explain that. So you can see here, this is a building without outrigger. So this way the moments are developed under the wind load. This is the wind load. This is a shear wall without outrigger, and these are the moments developed. With this introduction of outriggers, you can see here, these moments are reduced here, and the deformations are also then came within control. And not only the deformations are important, comfort level accelerations under wind loading is also important. I mean, whatever the accelerations are developed under extreme wind conditions, they should not disturb the residents. They should be within the limit of perception, and the comfort criteria should not be disturbed there. So that way it was done. These are the 3D models. So complete structural models are developed. Their dynamic behavior, static behavior. They are loaded with different loadings, gravity loads, lateral load, that are wind loads and seismic loads, and then the forces are analyzed.
So I just want to add one thing out here. You know, in a normal buildings, like we used to do the earlier times, we used to do buildings. The architect used to do the building and then used to pass it on to the structural engineer. Okay, now give me the columns. Whereas you do a high rise, it's no more that way. You have to start working in conjunction right from the day one when you start planning. So you have to involve the structural engineer, you got to involve the MEP consultants, and you have to get the facade consultant in as well. We don't have the facade consultant today, otherwise he could have given a better picture of the facade. So, you know what the other thing, I mean, the MEP people would be able to give you a better idea. We've got service flows in between, and those service flows are used for the outriggers, as well as we've got our services, like, so we have breakwater tanks, we've got various other services. I think it's Pragnesh's this thing, he'll be talking more on that. So that's...
Yeah. So structurally, these are the modes up there. Now it is perfectly ideal what way it is required. So first two modes are translational modes. One is like this, second is like this, and then the third is in torsion. So these animations are showing you that. Strength demands are critical. Naturally, from foundation, above foundation, the starter columns started with M70 grade. One more achievement is done in here. Steel grade Fe 550 is used. So that is a new change has come up worldwide. ACI 318 2019 has allowed now use of equivalent of Fe 550 in US. And same way Indian IS 13920, Amendment 1 and Amendment 2 now allow you to use Fe 550. In the market, the price difference between Fe 500 and Fe 550 is just negligible. But there is a saving potential of 5 to 7% in using this Fe 550. So Fe 550 steel is used here. And grades are reduced as you go above. These are typical load intensities considered depending on the use, particularly passages, corridors, live load, utility areas, and all that is used. Seismic forces also need to be considered for such structures. Mumbai seismic zone is considered. Zone 3, it's a moderate seismicity, and all these seismic parameters are considered. Shear wall type of system is considered here. Ductile shear walls are used for resisting lateral loads. Of course, as the height goes on increasing, seismic, as compared to seismic, wind forces becomes more critical. And again, the evaluation of wind forces need to be very precise. And for such buildings, we recommend to perform the wind tunnel test. So this is the wind tunnel test done by RWDI. This is the setup is there. Actually, wind flows in different time of year in different directions. So this all load are evaluated for 36 cases. Each 10-degree load, what is the load coming for that particular wind flowing in that direction. So this way all 360 degrees are covered and 36 basic wind load cases are evaluated, and then they are applied to the structure. Yeah, here was there. So now these are the permissible deflections, H by 500, These are 512 millimeter, and with the proper outrigger arrangement and all this, we have achieved it at 360 millimeters and 360 millimeters in X direction and Y direction, which is quite a fair number. This is about wind-induced acceleration comfort criteria. So for this residential also it is up to mark, it is not exceeding the mark. What happened under the winds, extreme winds, structure starts oscillating and accelerations are induced in the structure. They are not, from safety point of view, they are not critical, but from comfort point of view, they are critical. So different agencies, ISO, RWDI, they give this particular number, value of the acceptable acceleration level. And then that acceleration level is achieved here. So for a 10-year return period, the peak acceleration is 16 milli-G. So 16 milli-G is what is felt as comfortable. One don't feel it as a disturbed one. Yeah, so I hand over it.
Designing MEPF is a very critical for this super tall building of 250 meters. So, so these are the requirements, per day requirements of electrical, water, and the fire. Just go to the next slide. In this 250 meter, the services has been planned in such a way to keep the residual pressure within the limit of 4.2 kg as respective levels. Just go back to. So we have planned a service floor. So we have planned one service floor at the bottom of the typical floor, which will take care of your drainage, entire drainage system. The middle service floor has been planned to take care of the brake pressure tanks and to take care of the ventilation system of the internal toilets. The top service floor has been considered to take care of the penthouse services, which will be different from your typical core. So these are the general flow diagram of electrical system where we are using the bus duct systems for the power supply to the respective floors, which are DG backup for emergency services. So this is a water supply scheme where we are getting a water from BMC at your underground level, then we are pumping that to a second service floor level, then again we are pumping to the terrace floor, and then we are distributing at respective service floor to keep the pressure should not exit more than a 25 bar, which will take care the cost efficient building and a cost maintenance building in future.
Hello? Yeah, so this makes it more sustainable. So you don't use that much energy to pump the water right up to the top. You're pumping it to an intermediate level and letting it flow by gravity and then the other flows as well.
Yeah. So there is the same strategy we have applied for the firefighting system. So we are putting a three level of firefighting tanks, which will be fed from bottom to the mid level and from the top to the mid level. So these are the few coordinated layouts. This is a basement layout where we have a STP, water tanks, and the other accessory services which has been staggered in entire basement.
So this building, we've done it with BIM because, you know, there's a lot of services that are coming in and the structure. So, you know, we got to look at it first before we get into construction, especially the service floors with his outriggers was a major problem, you know, fitting in the water tanks, fitting in the electrical panels and all the other services as well.
So these are the podium parking levels, which has the same MEP services. So this is a typical floor plan, is a plan with a very efficient way with a service cores where we have a bus duct shaft in the next to the staircase, firefighting ELV shafts, which is centrally located and equally distributed to the entire to the apartments.
So what we are doing here is we are not taking, we're taking meter rooms on every floor. And there's a bus duct which travels from the ground to the top. We don't have cables running all around the building. So there's no energy loss because cables, there's a lot of energy loss in them.
So these are the blown up drawing of the core shafts and the few of the plumbing shafts where we are keeping ODU space to get in a proper ventilations. So this is a service floor which we got a lot of challenges to coordinate with the structural outriggers and the diversion of the drainage line. So this is the heart of the building where it's required a lot of effort to coordinate with architects and the structural.
So here we still don't have the water tanks are not shown here.
No,
the panels are not shown here, but once you see all of them together, it's a real mess and a maze. And, you know, working them all together is a nightmare.
So this is a middle level of service floor where we have water tanks and a water supply loop for the bottom part of the tower.
So these are the various views and so when you look at it from the marine, when you go into the boat and you look at it from the sea, the Bay of Bengal, the bay, Mumbai Bay, you can see that you have the Princess Street Bridge and you have the tower in the backdrop. So as I said, if you see, we have these as individual windows. And we have a lot of sit-out areas because after COVID, everybody started demanding. We didn't have it initially, the balconies. Everybody started demanding. They said, we want balconies because if you're locked up in the house, you need to have some fresh air and you want to get out. That's how it fits on the Queen's necklace, the gem. So that's one recreational level out here, and then we have another intermediate recreational level up there. And when you see from the tower, you can see the entire necklace. So as myself, I'm Reza Kabul. I started the firm in 1988, and we have a studio in Pune and we have a studio in San Francisco. And over the years, we've done a lot of projects. We do architecture, interior, and master planning. So these are some of our projects completed. So this is actually, when you call a vertical city, I just put this for that. So this is like a vertical city we are doing in Colombo. For right now, it's on shelf because of the Colombo, this thing. But, so this is like a vertical city where you have the retail component, then you have got commercial, residential, and each of them have their own, you know, recreation areas. And then we have the hotel, which starts from here, and there's an observatory deck. And so this is a vertical city. So once you get into this place, you know, live out here, you enjoy yourself, and everything happens out here. The other challenge that what happens in a tower like this, I just want to bring this point out. There are various users and they have to function independently. Their drop-offs have to be taken care of independently, their loading, unloading, their garbage, their services. So this is a big challenge. We worked out the entire tower, we started it, but it's on hold. This is another 3 towers we are doing in Mumbai, which is again 250 meters. These are 3 towers completed in Mumbai. This is another tower we finished in Mumbai, and it was awarded the International Property Awards. So it's a sustainable tower, and it's a very demand, and it's a very high, expensive tower, luxury tower. This is another one which is half done in Mumbai, in Bandra. It's under construction. That is Nagpur's tallest tower, 118 meters, almost nearing completion now. That's another tower we are doing in Nagpur. So, I mean, all the tier 2 cities are getting it. So, Nasik's also not going to be, deprived of it. You're going to get it, but then we have to plan for it properly. That's another tower in Mumbai. Another one in Mumbai. So, that's Ahmedabad's first commercial cum hotel cum retail tower. It's a Taj, and it's got retail downstairs. There are 2 towers. The second one is under construction, and the Taj is on the back. That's the drop-off and the... Thank you. Any questions? Please. One second. The projected cost for this thing and the timeline. The project cost is around 7,000 rupees a square feet, construction cost. And the timeline is about 5 years. So it's about a year that we've just come out of the basement onto the ground level. And now it would go fast because now we are getting the the aluminum shuttering that's coming in. So it's going to be typical and we're going to move much faster. So as we say, the basement had the major challenges, the soil and the raft that was 2.8 meters, and how it was done with ice, so that the concrete doesn't crack. So there was a lot of challenges that we had, and normally basements have challenges. So now we should be moving much faster.
I have one question for the structural consultant. Can we go to the structural plan?
Okay. Don't ask me difficult questions.
Not for you.
Okay. Yeah.
That typical floor plan, can we just
Typical?
before that? This
Okay.
slide. So now, can you explain me what is the aspect ratio of this building, especially at the ends? Those wings which are projecting out. How you have calculated the aspect ratio?
See, now this shape has an advantage. If you look at the X direction, it's a larger dimension. In case of Y direction, what has happened, these wings are helping to the extent, some extent, if you are talking in terms of aspect ratio. But here there is a localize, if you say, in this portion. So there is a need, and that's why this core is strengthened and stiffened with the help of outrigger arrangements. That way it is achieved.
But as we, I just want to know that in the bylaws in Mumbai, more than 1:9 they don't allow. So does it fall in that category? 1:9 aspect ratio, does it come below that?
Yeah, I mean, if you look at the height, the purpose, sole purpose to restrict in 250 is our high-rise code allow buildings up to 250 meters and aspect ratio and the structural system. So whatever are the guidelines of IS 16700, 2017, that we have perfectly followed in this. And even if it crosses beyond that, then there is a expert review panel provision. So you can submit your proposal to them, they review it and.
Yeah, we have a peer review structural engineer on the project, and they did the entire peer review, and then we got the clearance. And what happens is here, I mean, it's his subject, but this whole thing becomes like a core. This whole thing becomes like a core, and that because of the dead walls, he got the stiffness over here. So this entire thing has got a stiffness because of this core, dead wall that we got.
And the beauty of, means we got this is adding to torsional stiffness also. So it helped us to, bring down the torsional mode to third position. That is
Great. Great design. Thank you so much.
Thank you.
So the question is to you, what are the intervention of handling the torrent drain, which is just facing the entire Marine Drive? Architecture intervention. What are the architecture intervention as a designer you have considered handling the torrent drain of Mumbai?
The rain for
Yeah,
the Mumbai, okay, that is handled by the facade consultant. And the reason why we did the individual things, is so that we don't have a curtain wall. We didn't want to go in for a curtain wall. We wanted to control the price. And by doing it individually, because what happens is we've seen in a curtain wall, the water, once it gets into the system, it gets out and it goes where nobody knows. And then how to track it, it becomes a challenge. So that's why we've worked out a system which is every floor, individual floors, and it makes the construction also faster because it's like a unitized thing. It will just come and it'll go into the opening, apertures.
And so in such kind of building, what is the freedom the RCC consultant give you for the sleeves in the shear walls? What is the maximum sleeves you can carry in the shear walls for the services?
So it is, it's a give and take kind of a thing, and we go a couple of times up and down till we actually come to it, and we have a lot of fights on these kind of projects. It's not easy, and that's why we bring them in on the inception stage itself. And then, all these dead walls that we considered, we did it. So what Saurabh's question was, it is a very good question what he said. And when we did the plan, we thought of it ourselves because it was I know that the building will go in torsion because this becomes like a separate arm. But this dead wall that you see, it gave it the stiffness. And that's how we could manage doing this building. And you see all the flats have got the views, all the views, like that's the living room, the bedrooms, all of them are facing the sea. So there's nothing on the back. It's only the kitchen and your toilets and the other services. Yes, any other questions? Vivek?
I'll ask you once you are done this.
Okay. Okay, thank you very much.
Thank you.